right, so the first step you're going to do on all these is graph on a graphing calculator. Okay, so you need to pull that open, and in your y equals, put in that polynomial, because we want to see by the graph where roots are occurring. Okay, where is it crossing the x-axis? So let's graph x cubed minus 9x squared plus 27x minus 27. Oops, what did I do wrong? Oh, there's a comma there. What should it be? X cubed minus 9x squared plus 27x. There we go. Okay, so if I graph this, I can tell you one root. What is it? Where is it crossing the x-axis? At 3. Okay, so I know 3 is going to be a root, and I can double check myself by going second graph, and when x is 3, y is 0, that's proof right there that yes, 3 is a root, right? Your roots are when y is 0. So we're going to go over here and do synthetic division with 3 to take that out. So 3 in my box, and then 1, negative 9, 27, negative 27. And if I do this right, it should be getting 0 as remainder. If you don't get 0 as remainder, you maybe calculated something wrong. Bring down the first term, multiply, add, multiply, add, multiply, add, and I get 0, right? So how did this help me? If I look at my answer here, remainder constant x, x squared, I end up with a quadratic. Once I have it down to a quadratic, right, I started with cubic, which was not factorable, so no way to solve. But by taking out that factor of 3, I then have it down to a quadratic. I can solve any quadratic, either factoring or quadratic formula. Of course, I want to see if it's factorable. That's easier and faster. Is it factorable? Can I multiply something equal 9 but add equals negative 6? Mm-hmm. So what happened that I couldn't see on the graph is that 3 is my only root, and it happens 3 times. That's how I get my 3 roots, right? Because it's cubic, so I need 1, 2, 3. And I couldn't see that on the graph, so I needed synthetic division to help me find the other 2 roots. So you can either circle and tell me those are your 3 roots this way. Another way, if you remember, you can answer is x equals 3 with multiplicity of 3. All right, you can also do it that way. Let's try another one.
Is this all we're doing?
Mm-hmm. All right, so again, a cubic polynomial, so how many roots do I need? 3. Okay, so let's graph it and see if there's any I can use synthetic division with. So 2x cubed minus 8x squared plus 18x minus 72.
Can you not take a 2 out of that before we put it in the graph?
Graph, and then what's a root? 4. Right? So I'm going to do synthetic division with 4. Okay? So 4, 2, negative 8, 18, negative 72. And that should get this cubic down to a quadratic. Bring down your first term, multiply, add, multiply, add, multiply, add. So remainder, constant, x, x squared. So look at this quadratic that I have. Okay. To find my last 2 roots, right, I know x is 4, that's a root, but I need 2 more. I can do quadratic formula, but the easiest way on this one, since I only have an x squared, is just set it equal to 0 and solve. That'll be the fastest way. So set equals 0, subtract 18. Divide by 2. X squared equals negative 9. Then what? You want to square root both sides. So I get x equals plus or minus I. Okay? So that's why I couldn't see those on the graph, because I have two imaginary roots. You're not going to be able to see those up here. So the 4, I could see and use that to get it to a quadratic, which I know how to solve any quadratic and get my other 2 roots. So 3 roots, positive I, negative 3I, and 4. Again, this is a cubic polynomial. So how many roots? 3. So let's graph it. Y equals, right? Let's put it in. X cubed minus 10x, minus 12 graph. Okay. So this one is somewhere between 3 and 4. I don't know. But this one looks like negative 2, right? So if I go to my table and look at negative 2, yep, 0, y is 0. So I know that one for sure. So let's do negative 2. So 1, 0, don't forget your 0, right? There's no x squared term here, so I have to put a 0 in for that. And then, bring down my first term, multiply, add, multiply, add, multiply, add, I'm good, right? Remainder constant x squared, right? I get a quadratic as my quotient. So I need to solve this quadratic to find my last 2 roots, because right now I only have negative 2 as a root. I need 2 more. So is it factorable? Can I multiply equal negative 6 by add equals negative 2? No. This one you're going to have to do quadratic formula. So x equals, right, negative b, right, this is my a, b, c, negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a. And remember I showed you how to put this discriminant in your graphing calculator? You go ahead and just put that in to get the answer. So 2 plus or minus square root of what? So you go parenthesis, negative 2 squared. Whoops. I showed you guys how to do this, right? No? How come I can't get negative 2 squared minus 4 times 1 times negative 6? 28. Well, that's easy. Why didn't you show us that before? Just show. Okay? So then I can get from here to here very quickly. Right? But this is not done because why? You can simplify this 28. Very good. 28 is 2 and 14, and 14 is 2 and 7. So there's 2 2's. I can take 1 out. So I'd have 2 plus or minus 2 root 7 all over 2. Still not done because I can take a 2 out. So my last step, I'd have 1 plus or minus square root 7. Okay. So if you look at your graph, you can kind of see this is probably 1 plus square root 7. And then over here is 1 minus square root 7. Right? And 1 minus square root 7 is very close to a negative 2. That's why it's hard to see. It's crossing in 2 spots there. So those are my 3 roots, right? So somehow I would circle them, or I could write them up here to tell my teacher, here's my 2 roots and I answered the problem, right? You got to write them somewhere that I can see.
So what do you do when it's like
5th degree polynomial. This is the first one on your homework. How many roots should I need? 5. Okay, so let's think about this, okay? If I have 5 roots, right, every time you do synthetic division with a root, it brings it down by 1 degree. So if I know it's a 5th degree polynomial and I need it down to a quadratic, how many roots should I find? 3. Because 1 root would bring it down to a 4th degree, another root would bring it down to a cubic, and then a 3rd root would bring it down to a quadratic, and I can solve any quadratic, right? Every time you use synthetic division and take out a root, it decreases the polynomial by 1 degree. So 5th degree, I need to get 3 of them to get it down to a quadratic. Okay, so let's graph. That's always your first step, is graph. So let's see, x to the 5th minus 3x to the 4th minus 8x cubed minus 8x squared minus 9x minus 5. All right, so do I have 3 roots? What I want you to remember is we talked about this last chapter and a little bit this chapter. Whenever you have a maxima or minima hit the x-axis, that has a multiplicity of 2. Right? So if I had a graph, and let's say it went like this, and hit the 3 and came back up, I would say 3 is a root with multiplicity of 2. Right? Or if I had a maximum, let's say, that hit right here, that's hitting -1 or -2, I would say -2 has a multiplicity of 2. Whenever your graph comes up and hits it and goes back down, or comes down and hits it and goes back up, it's always going to have a multiplicity of 2. So even though I see 2 roots here, -1 and 5, -1, if you notice it hits it and comes back down, that's going to have multiplicity of 2. So -1 is actually going to happen twice there. Okay? All right, so what you can do is a chain of synthetic division. Which one do you want to do first, -1 or 5? Okay, it doesn't matter. -1? Okay. So bring down your first term. 1 times -1, add, multiply, add, multiply, add, multiply, add, multiply, add, and you should get 0's remainder. Now, since I'm doing multiple roots, I can just keep doing synthetic division. So what do you want to do the second time? Do you want to do the other -1 or do you want to do 5? 5, okay. So from right here, I'm going to set up synthetic division of 5. Do not include the remainder. That's never in your synthetic division. You're only going to go till -5. So then again, bring down the first term. Multiply, add, multiply, add, multiply, add, multiply, add, and you get 0 again. Right? So this is what I know. X equals 5, that's an answer. X equals -1, that's an answer. I still have one more root to put in. -1, because we saw that had multiplicity of 2. Bring down the 1, multiply, add, multiply, add, multiply, add. Okay. So what do I know? I know these 3 roots now for sure. I just proved they were roots by getting 0 as a remainder. But I need 2 more. So luckily, right, this now, remainder constant x squared, is a quadratic that I can solve. And it's a pretty easy quadratic. It's x squared plus 1. Right? That's what I get from here, because it's 0x. So it's just 1x squared plus 1. And from here, I can set equal to 0 and find my last 2 roots. A lot of you can probably do that in your head. Plus or minus I, because you'd subtract 1, square root both sides. If not, go ahead and work it out. Square root. So plus or minus I. So do I have my 5 roots now? Yes. Here's 2, positive I, negative I. And here's my other 3. So altogether I have 5 roots. All right. This is a 4th degree polynomial. So how many roots do I need?
4.
4. Very good. So let's graph it, see what we can find. So y equals x to the fourth minus 2x cubed. Oh. Minus x squared minus 4x minus 6. Graph. All right, what do I have? -1 and 3, and I can double check that, right? -1, yep, it's 0. 3, yep, it's 0, right? Double check. So which one do you want to do first, -1 or 3? Okay.
Does it matter which one you do first?
No, it does not matter which one you do first. So bring down the first term, multiply, add, multiply, add, multiply, add, multiply, add. 0 is my remainder, good.
Trying to chill.
X equals -1, that's a root, good. Then you need to do the other one.
If it gives you a calculator, like, you know how like x equals 0 or y equals 0 wherever the term you use is? You know what I'm saying?
So 0 remainder, this is a quadratic. So I get x squared plus 2, right? So now I have 2 roots, -1, 3. Here's quadratic, I could find 2 more roots. The easiest way is just going to set that equals 0 and solve. -2 on both sides. Square root. So x equals plus or minus I root 2. So there's my 4 roots. Done.